Good afternoon, professors. Today now, for this session, we'll just have the basic implementation of all the four types of linked list. So as Revati ma'am explained in the previous sessions, so I think we first saw about single linked list first. So what is a single linked list is, as the name implies, we will have a single data value and a single next address value, right? So this next address will point to the next node present in that particular list. So the final node will be consisting of a value. So I'll just tell you why we have this last node named as tail in some next few slides. So I'm audible, right? Am I audible?
Yes, ma'am.
Thank you, ma'am. So now we'll see the structure of how a single linked list will be. So as we have mentioned here, we have one value part and one next address part, right? So here we have that value represented as data, which belongs to integer type. So this is not necessary that we should have data of integer type. This can be of character or boolean or whatever according to our convenience and necessity. So this next represents the next address of our node. So here we have two extra objects for pointing to the nodes present in our list. So one we have it as head, the other as tail. So these two are initially initialized to null. So this means that we don't have any node present in this particular head and tail or any address present. So we can see here this is of type integer and this belongs to pointer type. So all the objects that we have created belong to pointer type because except this value, all other things represent only the address of nodes present. So this is a variable and these three things are used for representing addresses. So that is what is the major difference between a linked list and an array. So in array, you'll be pointing only to the positions or index values, right? So whereas here, we are going to point to address values. That is why you are using pointers. So this is one way of writing. The other way could be, so after closing your structure, you can just declare these two pointers. So this is another way. So I'll just explain the code first and then we'll go for the implementation, direct implementation. So first we are trying to insert a node into a empty list or a node into some list which already has some other nodes. So first, for all types of insertions, the first main thing is creating a node. So for that, what I'm doing is I'm just creating a node called as. So for creating a node, I'm just having an object declared first. So which means this particular new node is a pointer which belongs to the structure node. So this is the node which we have declared here. So this struct node, we are making use of this node and creating an object to access the values present in that particular structure. So next is our memory allocation. So for a memory allocation in C programming, we are going to use malloc, memory allocation. So which here it is used as malloc. So using that malloc management, we are going to allocate memory for the created object. So what could be the memory allocated is, so whatever memory you have allocated for this particular structure, so that I am in need for my particular new node. So this is what is this line explains. That is, I have a structure called struct node. So that will be allocated with some KB or bytes of memory, right? 8 bytes or 10 bytes or 16 bytes according to your compiler. So that size exactly I'm using it for my new node. This is what is these two lines infer. So when these two lines has been executed, obviously you'll be having linked list node created. So with two parts, one is data and next address, and that will be named new node. So this is this is the address that has been allocated. So we all know address will be of some 16 digits, and for our simple reference, I'm just using this particular value. So will this be the value for the first node created? No, obviously that is not the case. So for our reference, we are just using some random values. So after these two lines, we'll execute the next line. So here, uh, maybe in the previous line, we have created the structure of a node. So maybe the next part will be getting value for this part and this part. So here I'm just scanning the value of data part. So using scanf, percentage G and ampersand, new node belongs to data. So this means for this particular created node, I'm getting value of the data part. So once that is done, I'm just allocating my next address to be null. So why that has to be null is you are the first incoming node or you are the only node we have created now. We will not be able to know the next particular node that will be present in our list. So in order to maintain that, we are going to use null as our address, next address part. So once this is done, and this will be your content of your list. So this is how your list will be looking like. So we have created an object to access structure node, and we have created memory and scanned our data and given our next stages. So this is how your data will be. So next, what we are going to check is whether our list contains some nodes or our list is empty. So this is what is the condition we have to check. If our list is empty, we know that this is our first node and this is the only node into our list. So for that, what I'm going to do is, so as we have already discussed in the previous slides, I'm going to have two pointers. One is called head, the other one is called tail. So the incoming node, if the list is empty and there is a node which is incoming, so this means that is our first node which is pointed by head, and that will be our last node towards the list. So I'm pointing that using tail. So this will be, yeah, this is the representation that you will get when you execute these two lines of statement. I repeat, I'm checking why I'm checking for this head equal to null list. What if my list is empty and if this new node is the first node that is incoming towards our list. So to know that if your head is empty or null, this means this is your first node and this is your last node. So I'm just pointing both head and tail towards our new node. So I mean new node has been assigned, that new node's address has been copied to tail and head. So this is how your structure will be. Suppose if this is not the first incoming node, if the list already contains some other node, so how the data could be represented as, consider this to be your already present node. Okay? So say you have head and tail with three nodes in your list. So what happens is we have to insert this particular new node towards the beginning of the list. So that is what is our operation, right? Inserting in the beginning. So what I'm doing is I have this particular new node created and I already have this set of nodes present in my list. So only two things has to be changed. One is connect this new node to this head node. This means I need to change this particular null towards next of head. So how I'm doing that is with the help of this particular line. New nodes next is equal to head. So this means this was previously null. So now this address has been updated with head's address, which is this particular 257895 address. So as we have seen here, head should point to the first node present in the list, right? So when this list is taken into account, you can see head points to the second node present. So now we have to make this head point to the first node present. That is, head should be assigned with the address of this particular node. So this means I need to update with another line, head is equal to new node. When this particular stuff is done, so you can see your head has been moved towards the beginning of the list. So now when you try to traverse the list, you can see the head starting with 56 as its value. When you move towards the next list, you can find each and every value present in the list. Okay. So at the end of this operation, if your list is empty and this will be your output after inserting new node, and if the list is not empty, so this is how your data will be stored. I mean, your node will be stored in this particular sequence. So this is how you will do insertion at beginning. So is this part clear? Shall I move on to the next operation? Okay, fine. So this we'll see how this is getting implemented. So first we'll see our single linked list. So we'll just see very basic operations as in the beginner's level. So we have insert begin, insertion at end, insertion position, likewise deletion at begin, deletion at end, and deletion at a given position. Okay. So now we have another function called as display to display the elements of our linked list. So initially, as we have mentioned there, we are creating a structure with data and next. So I have just declared head and tail as my objects to the list. So into the main function. So I have some 6 to 7 operations to do. What I'm doing is I'm just having it like a choice. So whichever operation you want, you can just enter that particular choice and make use of that particular operation. So for that, I have this printf, which just prints which input will give you which function. So if it is 1, that is insertion begin, and if it is 2, it is insertion at end. Likewise, I have 7 operations, I mean the functions display. So here I have while loop. So why I'm having this while loop with the condition true is, so we will not be able to know like how much number of times you're going to execute this. So what I have done is I'm just having a loop saying that I'm going to run it for infinite number of times. So when this loop will stop us, I'll have a default case. So where you will find this exit condition. So this exit will terminate your program. So until you just have this default case executed, your loop will be continuously executing. So suppose if I give, I'm just getting a choice here. If my choice is 1, I'm going to get an element from the user and I'm passing it to the function insert at begin. So when this is done, so insert at begin function will be called, which is present here. So maybe in our presentation, we just use scanf for getting the value from the user inside the insert begin function, right? So whereas here, what we are going to do is we are going to get it in the main function and pass it as an argument. So we have an element here, we are passing that into the main function. So which you can see here, I'm sorry, into the insert function, which you can see here, we are getting it as an argument here. The same set of code we have written, and this will help you to execute insertion at beginning. So when I just try to run this, so when I just press this run key, it is automatically compiling and running. So you can see here, first we have seen insertion begin, right? So first I'll give choice as 1. It's asking for element, I'll just give 45. So again, when I want to insert another node into my list, I'm just giving choice as 1 followed by the value. So you can see here first I have inserted 45 and before 45 I have inserted 67. So when I try to display it, you can see 67, next will be 45 followed by the null. Null in the sense 45 is next is null, I don't have any more present after 45. So when I want to terminate this, I'll just give some other value which we have not mentioned here. So say it is can be 8 or 10 or whatever. When this choice is encountered, you can see when these 7 cases doesn't have the given input value, the default case will get executed. So that has exit, which means my program is getting terminated. So this is what is insertion at begin does. So next we'll move on with insertion at end. So this is how an insertion at end happens, right? You want to insert O, this is compared from the first node present in your list, as that node have is the end of the list. And if that is the end of the list, you are going to insert that particular value at after the last node, right? So this is how a normal insertion process goes on. So you can check the time complexity here. We have 4 nodes present in your list, and you're going to insert the incoming node as the fifth node. You're going to traverse all the 4 nodes present in your list, making your time complexity to get higher. So that is why we are having this particular tail node used. Okay, you can see here. And these codes are same as you did for insertion at beginning. So when you're trying to insert into an empty list, this particular coding doesn't change at all. Same code. So suppose if you are going to insert into a list which is already having some nodes present inside, so this is how it goes. We have a list. So you have head here and you have 4 nodes. You have tail here, right? So what the logic behind the insertion at end is, just start with the first node, check for the last node, and when you have reached the last node, insert the new node created, right? So this is what is the flow, and that takes the entire list as its time complexity. So now what I have did is I already have a node named tail, so which is pointing to the last node present in the list. So when I access the tail directly, you can access the last node present in the list. So what I'm doing is I'm just checking for the tail node, and directly after the tail node, I'm inserting this particular new node. So tail's next address is null here. So I'm replacing this address with new node's address. We have tail connected to new node, but only problem here is we have already mentioned that tail should be pointing to the last node present in the list, but this is pointing to the last before node, right? So now I have to make my tail move to this particular position. So what I'm doing is I'm going to have tail assign the value of new node value. So that is what I am doing it here. So after this, this is how your list will be. It means I have head here and the last inserted node to be my tail node. This is how insert at end goes. So that we'll check it here. So at case 2, I'm scanning an element and passing it as an argument to insert end function. So this function in turn, this comes here and the same thing. I'm just creating an object for the node using memory allocation and assigning values to data and next extra address. And if my list is empty, I'm assigning the node to be my first node and last node present, or else these 2 lines of code. When I execute this, suppose you have some already values present. Say you have 3 and 1, which has already been into my list, and I want to insert another node at the end. So I'm just giving the choice as 2 because that is what is insertion at end represents. So moving towards that value, suppose if I insert 55 as my node and display it, we can see here we have 3 and 1 which are already present in our node, followed by the recently inserted node which is 55. So that gets inserted at the last of your at the end of your list. So this is how insertion at end goes on. Next, we'll move towards insertion at a given position. So when you want to insert between two nodes, so this is how we are going to insert. So when we are trying to insert E after H, the first thing they do is insert E, update E with the edges of the next node, after which before which E will be getting inserted. So after that, I'm updating my previous node's address. So this is how insertion in a single linked list using position goes. So you can see here. So you have a value called for PTR, which is the new node that has to be getting inserted into my list. So say its position is 3. So what I'm doing is I can't directly go to the third node and ask it to shift. So instead, what I'm doing is I'm just creating a pointer called as temp to refer to the position before the insertion of the particular node. So if I'm going to insert this value as the third node, I'm going to make temp point to the second node present in your list. So why this is done is we can't suppose you just think of the another way, like you had this particular linked list, right? So this particular linked list, suppose if we want to insert a node here, so I have head pointer here. If I move this head pointer to this position and insert the given node, what happens is this head has been moved to this point, so which means you will not be able to get this particular address again because we don't have a condition like moving backwards. Only forward is possible. So once you move forward, the accessing of the previous node is highly impossible. So that's why we don't involve in that particular action of moving this head or tail node towards front or back or whatever. So that is why what I'm going to do is if um, the usage of alternate present pointers is not possible, we are going to create a reference called as temp, an object to access that particular structure node called as temp. And with the help of temp, we are going to access the values present. So the same thing goes here. If I'm just scanning the position. If my position is 1, what I'm doing is I'm just calling insert begin function. So why? Because if I want to insert a node at position 1, this means you're going to insert before the head node present. So this is my first node, second, third, and fourth node. So I want to insert at position 1, this means I'm going to insert a node here and pointing it by the head node, right? So for that, I'm calling insertion at begin. Now, if my position is count plus 1, this count, what is this count is representing us? I'm just going to count all the number of nodes present in my list, and that value will be stored in this particular count variable. So count plus 1 in the sense, if your list is of size 5, I want to insert at 6th position, right? So this means I'm going to insert after the last node. So that represents insertion at end function, so which I'm calling it here. If your confusion is greater than count plus 1, obviously that is not possible, right? Suppose you have number of nodes to be 4 in your linked list, and if you want to insert it at a position 6, so this means you're going beyond your boundary, so which is not possible. So if these are not the position values, and we are moving towards the else part. So what this else part contains is we are going to create the same object new node and the same memory allocation and empty, if it's an empty list, how we are inserting. Okay, so for next, we are just having temp here. So why? Because if you move head or tail from that particular position, you will not be able to go back to the same position, right? So instead, we are having another object created called temp, and that is assigned the value head. So now, if you want to insert at the third position, you're pointing this temp to the second node present, right? So for that, I'm just using this for loop and making temp shift to next values available. So once it is shifted, what I'm doing is this new node's next address is getting updated first. Why we have to update this new node first is when you try to update this particular address, what happens is the SIM gets disconnected and added here. So if this is not done initially, so and if this is your first step, like you are putting your things next to this point to the new node, what happens is these three nodes will get disconnected from the list. So these nodes will be present in the list, and the only thing what we do is we will not be able to access these values because we will not remember the address of these nodes present. So that is why the first thing we do is we just make the new incoming node's next address point to the exact node to which it should point to. So that is what we are doing here. New node's next is equal to 10th next. And finally, 10th next to this is equal to new node. So this means first we are updating new node's next address and then the previous node's next address. So this code we can visualize it here. So the same logic we are just passing an element here. So I haven't checked for those constraints. These three constraints which I haven't checked there. If you want, you can do it. So we'll do it. And the position plus one insertion between A and insertion at n time again. If it is not possible also, I'm just checking. After this, I'm creating else pad in which I'm doing all other content. And pass the element, right? Maybe the way of coding differs from time to time. That is why we haven't found it. One second, just maybe I'll have a global variable count, and each time insertion is done, I'm implementing my count. So after inserting given element, I'm incrementing my count. So this means after deleting, I have to decrement my count value. If you want, you can display count also. And now maybe this. I just copied the code, so which means this every code will have a different structure. Basically, we have this something I check once. So this, yeah. So else part, I'm creating a node, open else part. So after this, I have to close this and complete number of nodes present. Suppose I have given position as 3, or I mean the choice as 3, which means I'm going to insert at a given position. So suppose if I just say my position to be 0, so that is element, and my position to be 0, so it means that is not possible. So again, if I just give a choice to be 3 and the element to be some 45, position to be 1, so that is getting inserted. Let's see here. One second, I just give slashing. Just not possible. In one more condition, if the position is less than 1 and greater than, because if your position is 0, our node starts with 1, and 0 is not countable. So let's check again. I'll just directly go to choice 3 and let that will be my element. My question say it is some 9. And can insert that. I'm sorry, I have again scanned my question for the problem. I have scanned here. And now I think this will work fine. Say 3 with my element is 78 and question 0. And, okay. So initially my count is 0. Once again, just insert first. So say some element 45. I'll check I have Chronos present. So now I'll check with the code first. So I'm passing element, and when this question is called out, say if my question is 2, and this insert give the value 8, 9, and the position as. So you can see here, my data has been inserted at the value, I mean the position 2. So the number of nodes present is 4. Suppose if I give my position to be 8, so the stop in trying to stop. Okay. Which means this is not possible and encounters an error. We check that error. Okay, so this count should be incremented only at this point. So why? Because you can see here these lines of code. Okay, this line of code will count. I mean, increment the count value in insert begin, and this line will count the increment value in insert end, and this should not count. So that is why now this will execute fine. Okay, my question is 3. I get the value of the third position. So suppose I give choice 3 element to be 7, which was 8. So this is not possible. I'm sorry, this is our condition, right? So that is why you see I have inserted 3 values and displaying it. Suppose I want to insert 99 at position say I have only 3 nodes. So if I want to insert at position 5, it says it is not possible. So likewise, if you want to insert the same element at position 0, so that is place that is not possible. This is why, because we have just put it here, you can see you can just get the position value. If it is 1, I'm calling begin. If it is saying greater than the list of size by 1, so I'm just using insert end. And if those two conditions like position is less than 1 or it is greater than count plus 1, so this means that is not possible, or else I'm just trying to insert the values in between your list at a given position. So next goes for deletion at beginning. You can see when you want to delete a node, so when you want to delete a node, you can see it here. So this was my first node. After deletion, and you calling deletion at beginning, so this node has to be removed. So making this as my head node. So this is what we have done it here. I just make my head move to the second node, right? So once you make your head move from this node to this node, so that is done, right? When you try to print values from head, you can find only 20, 30, and 40 printed. 10 will not get printed. But one more thing, what happens is this tens, this head, the previous head nodes allocated memory will be present in the heap storage such so that memory will not be clear. So in order to clear this particular memory, we have the keyword called as free. So what I'm doing is I'm going to make another object which is called as del node and make that del node point to the first node present in your list. So say I'm making this as my del node. So say this is my del node. So after making a head move to this particular point, so I'm just trying to free this particular memory. So which means this will be erased from memory also. So in the previous thing, it just moved your head to this part alone. So it's just making your head move to the next one, which is just making the head move. I'm not deallocating your memory allocated. So for that, we can make use of this particular free. So likewise for the end, so this is if this is your tail node, you have to delete your tail node. So we'll check whether this is possible with the help of the reference pointer verification. So we have head here and tail here. If you want to delete these particular node, this has to be your tail node, right? So you have to make the tail point to this point. So we don't have any possibility of making a tail move to the previous node because this is your single linked list. You have only one um, next address part. You don't have any previous address part listed. So we need to again, if you're not able to do the operation, do an operation with the help of already present values, what we are going to do is we are going to have another variable called as temp, and we make the temp point to the previous node of tail, and with the help of that, we are going to remove our tail. You can see here, I'm making my temp point to the previous node of tail. So this is done with the help of this particular next. So when temp's next is not equal to tail, you are going to shift your temp towards the next node available. So at last, when this is false, what happens is my temp will be pointing to this node and the tail will be pointing to the last one. So now I can free this tail and make my temps next null. So this is what is done as this particular thing. So I'm making my tail move to temp and delete my, free my last node address present. So this is one way of writing, and you can use this as another way of coding. So each one's coding differs. You can have any kind of code. When division at a given question, that is very simple. So if you want to delete the third node present, move to the third node present and have an reference for the second node also, the previous node also, and just make this pointer, next address pointer, point to uh, the deletion nodes next address. That is what is the only change required, so that you can see it here similar to that. If your position is 1, you will call delete begin. If your position is the end, you will call deletion at end. And these are the conditions which makes it not possible for delete also. And if your head is null also, this means there's an empty list and you can't perform any operation. If not, we are making it 10.2. The node's previous address, and this del node is pointing to the node to be deleted. You can see we are making next node of 10 point to del node's next address, and finally freeing your del node's address. So this is what is done for deletion at the given position. So that you can just check it here. So this is deletion at the beginning in the same kind of coding, and we are using this count decrementation in order to count, decrement the notes, list of notes by one. So this is deletion at end, and finally deletion at a given position. So when you try to execute, you can see we have already executed and kept. So you have, we see how many nodes we have. We have three nodes. Maybe you add a remote nodes for our reference. So this is that. Okay. I go. So, so we have some 5 nodes present. Now we'll have operation 4, which is deletion at the beginning. So after checking this, you can see the first node has been deleted. That is 666. The value, the node with the value 666 has been deleted. If you want to delete at end, say 5. So I think 8 will get deleted, and that is that. So now we'll move on to the position. Suppose if I want to delete at the position 5, says I think again. I haven't checked. Yeah, I haven't given those codes here. 1 second, I will add that. Scanning the position. If my head is null, I can say I can't. Copying and pasting the code, you have to change your codes properly. If my position is 1, I'm calling delete quickly. If my position is large, I'm calling deletion again. If my position is, let's say, or greater, I say this is not possible again. So if this is not, else back, I'm doing all other operations. So this is my else close, and this is close, and this is my final function. Yes. Now, again, I'm compiling and another program. So this is 10% that also they'll know that here. So now I have some values already present. So now I want to delete a given position 1. So say I have my position to be 1. I can see it getting deleted. And the valid winners, if it is beyond the position, right? So say if it is my 5, so that is printing as not possible. And if I give a value this, they have a position say it is 3, 45 will get deleted. So this is how a values in linked list gets executed. That is the singly linked list insertion and deletion along with display gets executed. Does anyone have any doubt in this? Shall I proceed?